Welcome to GenPALS seminar on getting started with HPC3. My name is Tatyana. I'm in the Lawson Lab at UCI, and today is May 18th, 2023. A little disclaimer in the beginning. So I have to. I mean, I don't work at the RCIC, and I was not a computer science major, so some of the terminology here won't be like very fancy. And what I'm present today will be like best of my knowledge, but it's not perfect, can definitely be improved, so keep that in mind. And if anyone here is very new and you'd like to get started after today, please read the tutorials that RCIC provides. They really are very good. So whether you were or were not a CS major, some of these scripting concepts aren't actually taught in classes, so you kind of pick it up on the way in bits and pieces, and then you end up knowing it. But it kind of is a missing, I guess, curriculum in some sense, some of it at least. So today's outline will be as follows. I want to talk about HPC3, CRISP, which is the storage on HPC3. I'll talk about anatomy of a script, and then how to submit that, and also some interactive jobs, including command line and BioJHub. So what is HPC3? So it stands for High Performance Community Computing Cluster. It looks kind of like this. So you'll be a person that logs in through your laptop. You get logged into the login node, at which you have access to various compute nodes, but you have to request them in a very specific way, which I'll go over today. And also your data storage is also that same place on the cluster. So things that you'll need in order to use HPC3. First of all, you need an account. This is not automatically given to every student. You have to email HPC and request one. If you're working off campus, you need VPN. Regardless of if you are on or off campus, you'll still need two-factor authentication through Duo. You'll also need a terminal. I'm showing you here an example of a Mac terminal. So if you have a Mac laptop, it'll look exactly like this for you. The first one is a regular terminal. The second one is iTerm2. If you have Windows, you can install PuTTY or MobaXterm. I've heard very good things about MobaXterm, so maybe try that one if you don't have either one yet. And you will need a little bit of programming experience in Bash or Unix, but not that much. So don't be discouraged if you don't have any experience. You really only need to know, like, I think most of these over here. Since this is going to be recorded, I'm not going to go through every line here. I'll just be here for reference. You can look back later, pause and look at it. But you can already see this is like 20 things you need to know. It's not that bad. So first, we're going to start by talking about logging in. So this is done through SSH. So when you open your terminal, you'll see on your computer screen this big black, I guess, window. And on there, you would just type SSH and then your net ID for UCI, and then it'll follow by @hpc3.rcic.uci.edu. You press enter, and you'll get the rest of this. You'll be asked for the two-factor authentication, which you'll have to have your phone nearby to perform that step. And then once you're logged in, you'll see this login screen. And at the very end of that, there'll be the command prompt. This is where you'll begin typing whatever commands you need to do. On mine, it says base, and I think on most of them, it'll say base. This refers to the environment. If you have a specific environment that you make, the name will be name of that environment once you activate it, but generally it's just the base environment. Next, we're going to talk a little bit about the storage part. So there are three parts to it. The first one is your home. So when you're logged into the HPC, you're in the login node, but your location on the cluster is on the data folder, and then home's volume 0, 1, or 2. Mine is in 2. And I think a lot of people, not sure if it's school affiliation or what gives you specific volumes, but most people I've heard from have this volume 2. And then after that follows by your UCI net ID. So, this home location only you can access. There's a storage limit there, 50 gigabytes, which is free. You could save some files here, but generally this is not where you store your data in HPC. I'll cover that in the next part. However, here you could make some useful symlinks or shortcuts to the data that you will store elsewhere. This is to help you navigate later. And also this place is not for running jobs. We'll talk about that later, but this is just where you log in so that you know where you're placed once you log into the HPC cluster. The other two storage locations are on CRISP if your lab pays for that. Otherwise, you have a folder on the pub folder, I guess I'll say, where everybody has 1 terabyte of free storage, and that's limited. So if you have a lot of data, this won't be enough for you. So your lab should purchase some extra space on CRISP. CRISP stands for Campus Research Storage Pool. This is what your PI can buy space to store all your lab data at. RCAC made a nice app, I guess you would call this, called CRISP Desktop, using which you can access your data by just mounting this on your laptop, and then it's just like a click away. You can see things on the HPC and download them, upload things, whatever.
Does interacting with the CRISP desktop require like the dual authentication every time you like try to like click on something?
I don't remember. I know that if you do things at command line, if you have SCP, you do.
Yeah.
This one, I haven't done that in a while. I don't remember.
But was your question friendly? Maybe I know because I use the desktop version.
Yeah, it's very new. It's been annoying, but maybe I
Every single time you secure copy something from or to the HPC, you have to do two-factor authentication.
Recently, yes. It's I don't know, a year ago.
Ways around it, but I don't think we should put that in. I don't want to find out.
We will discuss offline.
Okay, we'll discuss that offline.
Sorry, okay, just to like kind of recap that discussion, I asked if you have to do any dual authentication every time you interact with the CRISP desktop, and the answer was we're not entirely sure, but we know that every time you try to SCP something from like your computer to the HPC, I'm listening to audio here.
Oh,
sorry. Yeah. Every time you SCP something, you do need to dual authentication. Okay, so Nargis says that you don't have to for the CRISP desktop, so that's super nice.
I think so.
Yeah,
I don't. Okay, can you hear
So
me?
I think I can move on from here.
I can hear you, Nargis. We're trying to get the speaker set up in here too, but
I just going to say that the desktop version is really good. The only thing is that it's a little
Sorry,
slow.
I could not hear you. So I can hear you now, but you're like in mid-sentence. Can you repeat that?
I just want to say that I work with the desktop version. It's really good. The only problem that I have is a little bit slow on reloading the stuff. But besides of that, it's good once because sometimes the SCP functions is funky in the HPC.
Yeah.
So the desktop version is good as well.
Okay, cool. Good to get that feedback. Well, here this is basically summarizes the ways you can up and download different files onto the HPC. So like we just now talked about CRISP desktop. Other ways is through FileZilla or WinSCP, and you can also do it at command line through SCP, rsync, or if you're downloading from the web, you can use wget. I'll give you that example, I believe next. So for example, when you're downloading sequencing data that came from your sequencing experiment, you would log into HPC, you'd make a location on CRISP or in your pub folder. So you'll go there, make a folder for your FASTQ, and then go into that folder and then download the data using wget. And when you get the email from the core, they tell you the location from which you can download the data, and you would just basically paste that in here. It looks very similar to this. At the end, you'll have your net ID and then a bunch of numbers. And at that point, it'll be ready for alignment with either BWA or Cell Ranger, or depending on what kind of sequencing data you have.
So I'm sorry, I've never seen something that looks like step 3 before. What is that doing? Is that pulling something from the like storage system on HPC, or is
this?
No, sorry, step 3 under 3.
Oh, downloading data?
Yeah. I mean,
It's just
like,
a
where's,
regular WGET.
that's just regular, but what were you saying about the core emails you about where it goes?
They email you the location from where you can download,
The genomics core.
right?
Oh,
an example.
got it,
Not,
okay.
not our kit, but
Got
the-
it, okay,
the
I was
genomics core,
confused
UCI
about that, I
GenPALS.
thought that, no, I was confused.
Okay. Yeah, yep. Yeah, the email has a lot of things in there, but they have instructions for how to download the data. Once you go to that instructions list, it's like the third or fourth on their list of different ways you can download it. If you don't want to do it manually, then you do it this way through WGET. So next I'll talk about submitting a job script to the scheduler. So you would use a job script for low to high memory jobs, but especially ones that take a long time to run that you can't sit there and like watch it. Sometimes it's overnight, sometimes it's a couple of days. So you know, can't really sit there and do this manually. Importantly, all the steps need to be set. And that's why it's called a batch, because all the steps are batched together and no interaction is needed from you. And it has a weird name called SBatch, but it stands for just a Slurm batch. And Slurm stands, also a weird word, but it stands for Simple Linux Utility for Research Management. So this is basically the scheduler at HPC that decides, depending on how many resources you ask for and like what your priority is, to kind of schedule your job to be done.
So also, the HPC is also really nice for things that you can run.
I'll talk about that. Yep. A little bit more details about submitting these jobs. So you can either they have two partitions. One is the standard one that's like 80% of the clusters allocated to standard jobs that you pay for either through your PI or the startup hours that you get for free. And around 20% is left over for free jobs. These are, as the name means, they're free. You don't have to worry about hours being used up for this. However, because there's less space allocated to this, you will probably have to wait a little bit longer sometimes. And the worst part is that your job can be killed in favor of someone else who is paying for a job and they need space, so you might get kicked off. The currency for these payments is core hours, and basically it's like one core CPU per hour is one core hour. Pretty intuitive with that, I guess. So next we'll talk about the actual JavaScript. You have to use a text editor to make a script. I use Nano. I know it's really old and not everyone's favorite, but that's what I use, so that's what I'm showing you an example here. But Vim and Emacs are more popular. So if you're out there and want to, you know, you're just getting started and you want to learn one, I guess pick those, because I know Nano's old. But in any case, I'm showing you here the beginning of a script. I'll show you the other steps later, but at the very top, you'll have certain parts. So you have the name. I made my the script with Nano, so I just typed in Nano and then cellranger.sh, which will be the name for the script, at the command line on the terminal. And then it would open this window where you basically copy or paste commands in from somewhere else, or you could sit there and just type them out, whichever way you prefer. In any case, in the beginning, your first line will be the path to the interpreter. If you're using a bash script, the first line has to be the path to the bash interpreter. If it's a Python script, it'll be Python path there instead. Next, you have submission details for the scheduler. If it's going to be a non-free job, you need to tell which account to charge, either your own, so you have 1,000 hours that you start with, or the PI. Also, it's helpful to have a job name. I don't think it's required, but I think it's helpful to have it there. And then how much memory you need. This depends on what you're doing. For cellranger, I Googled to see how much memory do you need, and it recommended 64. So that's what I put in. And the partition is standard, meaning that I will need to have allocated hours to pay for this. Next step will be you load whatever packages you need for that. If you need to make any variables to either different paths or something else, then usually they follow the here. And then something I learned very recently is on HPC3, you need to work in the scratch space that's made for your job. So you're not supposed to work in the directory in which you'll be writing the data to. Instead, you need to work in the scratch space. It's like I said, it's automatically made for you, and it's saved as already made for you as a variable called tmpdir. And you don't need to define it yourself. You just need to go there, made automatically. And then next thing is your actual what you're trying to do. So in this case, we're running Cell Ranger. So we're making a matrix from the FASTQ files. In the variables, I made certain types of variables that the Cell Ranger, I guess they're called arguments, are looking for. And in particular, I guess want to show the FASTQ path variable is when I'm actually calling it, it starts with a $sign, then with the name. But what it means is that I'm talking about this path over here. Same thing for the reference genome. And then, like, once that part is done, we will need to move the results, which are the same. There'll be a folder with the same name as the ID here. So I need to move that to the result where I want to store it. And that's also I made here with a variable. Otherwise, if you don't move it from the scratch space to your actual destination, it'll be gone, because scratch space is scratch space made for your job. And once your job is done, it's done. So you have to.
I've never heard of this temperature.
I haven't either. I was so surprised, but that's what you have to do, apparently.
Who says?
HPC3 admins.
I've never heard of this before.
Did they yell at you? Like, how do you know?
I sent them a script to ask them if I'm doing something correctly. It was about parallelization, but they were like, oh, by the way, you should use the, for good IO, I guess, input output stuff. You should not work on CRISP or DFS. You should work here. And they have I guess tutorials that talk about this, but it was very easy to overlook. I overlooked it, until like whoever I was talking to basically said it twice in the same email. Please do that. Please do that.
Wow.
Definitely the way that I run my job, like I can't do that too. Because like I run it using SnakeMake, and SnakeMake requires like relative file paths to where the thing is.
Yeah.
So like I'm not gonna like put the entire file path on every single file name.
I know. So I also have some stuff that I can't do that for. So I think because I haven't had errors with it, it's just, I guess it's a risky thing to do, but I haven't had issues with
I
it.
got a really, really mean email from HPC this week, and I am a good HPC user. So like, it was just like,
it's not the time.
not the time, not the time. But like, yeah, this is how you find out about Timpter, is if they email you about it. Because they don't teach you about it, at least not 4 years ago when I was learning.
Well,
how
they've
to use
changed
it.
the entire system.
Yeah.
So we haven't been like onboarded on it.
Yeah, that's true.
All the stuff they told us about 4 years ago is like completely wrong.
Yep.
No.
It was part of the MCSB boot camp, but it was not it was like we were talked at for 3 hours and there was no us doing anything. So it was real, I don't think anyone retained anything from it.
Yeah.
But technically they told us stuff.
Right. Well, they have the tutorial that technically is there. So like, I don't know. That could be.
I will.
Yeah. Okay. So once after that part, again, we are just looking at the anatomy of a script. I'm showing you here the text editor. So after you put in all the components to run what you're trying to do, you would save it. And I think there's usually an opportunity to rename if you don't like the name or something like that.
What does that caret mean?
Okay, so if you are interested in this text editor, the caret here is the control, and then this letter that it is. So like, for example, to save this, you would do Control O to write out, Control X to exit. But that's like very nano specific, and most people don't use this one, so I didn't want to like do a lesson on it because I don't expect
Okay,
people to
fair.
use it, but it's gonna be
It's on
different.
the
It's gonna be different for Emacs. It's gonna be different for Vim or whatever other one is there.
No, so this is running
This is-
through
this is
the
not control.
cluster still, so it's still on Linux. So it's the actual. Okay, got it.
Okay. Next, so after you've made that script, the way you'd submit it is at your command prompt on your terminal, you would write sbatch space and then the name of the script. I think technically for just submission scripts, it should be the suffix should be .sub, but my habit is to use .sh because it's a shell script. In either case, it'll be submitted. The way you monitor it is by typing in SQ -U and then your net ID, and it'll show you which jobs are either pending or running. If they're gone, if they're already run, they won't show up here. It's a different way to look those up. But if you're curious if your job has started, you can look it up this way. If you change your mind about something, you realize, the script isn't exactly what you wanted, you made a typo or something, you can cancel it by first looking up the job ID by going to SQ and then go to scancel space and then the ID of that. Everything that uses this slurm scheduler, all the commands start with S and then the other part of the word kind of makes sense what it does, but it all starts with S. Yep. Or slurm batch, I guess. Yeah. Some additional options that you can use, and these would go in the beginning of your script where you have the different sbatch commands. You can make error files and out files. By default, you'll already get an out file. It'll have errors in there if there are errors, but if you want these to be separate for like troubleshooting or whatever, there's a way to do that like this. If you want to get email alerts ranging from just the beginning, when your script starts or ends, or everything, including if it fails, you can indicate that also this way over here. There's also a way to only run your script for a certain amount of time, in particular if you're running low on allotted hours and you need to only use a certain amount of time, then you can specify that too. This is optional.
I'll also say for the time thing, because it has happened and it will happen again, is if the cluster is going down for maintenance, they will not let your job run if you specify more time than is in between when it's coming down.
Absolutely.
And the default is 3 days.
Yes.
So if you give your job more than like that amount of time to run, or if it's over 3 days and you didn't give it time, you can always dial that back using this option.
Yep.
And it'll run. So yeah.
That's a good point. And this time here is day, hours, minutes. So if it's only like, let's say 10 hours, you would say 0, 10, 0, 0. That would be 10 hours. Another option you can do is parallelization, the original way of parallelizing. So this is basically if you want to run your exact script, let's say 10 times, because you have 10 different samples you want to do the exact same computations on. Alternatively, I guess you could make a for loop or something where these would be done sequentially, which would take longer. But if you put them in this array, then they can be done all together. You usually have to specify which files you need to have this done on, and I'll show you the example of that next. Otherwise, it doesn't automatically know what you're trying to do, of course. This is, let me move this a little bit because I think it's covering up my title. Okay, so this is a script that is using the array for parallelizing. So in my example, I want this to be run 11 times. So I would specify that here in the beginning. And I cut out the part that has the path through the interpreter, all the other submission details. I'm just showing you the relevant one. So loading packages, whatever, variables, blah, blah. You need usually a file where you have paths to the samples that you want to run, let's say 11 times. In my case, I need 2 of them. I need the alignment files, which are BAMs, and I also need the barcodes. So I need 2 different separate files. Within both of them, there will be as many lines as this sbatch command is looking for. So in this case, 11. And on each line, there will be a path to a different kind of sample. So it'll be the full path, starting from /crisp/share, whatever. Next, there will be this part where you're assigning one of the arrays to one pair of, in my case, barcodes and BAM files. So this is the way you would do that, and the order of these must match so that they're paired properly and the script works correctly. The other stuff for this part of your script, and then here at the bottom is actually what will be run 11 times. Hope that makes sense. I will briefly talk about this because this is actually a very advanced concept, and you know it's not automatic. The multi-threading. So your program has to be multi-threadable. I guess I don't know if that's a word. You can't just set these things for any random old thing because it won't work. So the way you find out if you can multi-thread is you look into the documentation for your package, and if there's something in there about parallelizing, like how many threads you can specify, then you can you can do this. In this example that I'm showing you here, the way that we tell how many threads to use is with this @ symbol. In this case, just a random number, but 4. But you know, it depends on what makes sense for you. And what will happen here is that you'll have one input, which will then be split into 4 chunks, and those will be run in parallel and then joined at the end for like 1 output. This is to speed up some process, but you start with 1 and you end with 1. This is different from previous example in which we were basically running one script many times, and at the end we'll have many different output files. The way that you would specify that you are trying to multi-thread in an HPC script is to do it the following way. There are actually several ways. If you're very advanced and you know how to work with like distributed memory software, I guess, you can look up how to do the end tasks. But I don't usually do that, so I can't really talk about that. And it's kind of a rare case. You have to be like kind of advanced to do this. So we'll instead talk about the way in which I guess shared memory jobs would be run. So you would specify you want 1 node and 1 end task, and then you match the number of CPUs that you ask for to the number of threads that your software is expecting when you specify it here. And as long as these match, then that should work. And to explain a little bit of this, like what I mean, so it was kind of confusing. I had to like look this up in so many different places, but from gathering all that, this is how I believe this works. So we have an HPC cluster, has a bunch of nodes, not just 2. This is not literal, not to scale. There's a bunch of them. Within those, you have a bunch of CPUs, and so when you're multi-threading, you're using different CPUs for that job, and they have to be on the same node because this red one cannot talk to the purple one. They don't have shared memory. So in my example where I have 4 threads, there are just 4 CPUs here. They're on the same node. Also, there can be there are usually cores within the CPUs, and if you're doing hyper-threading, you can worry about that. But I don't think our HPC allows hyper-threading, so we're not going to talk about that. Just regular multi-threading, which works this way. Yeah.
So threading is basically useful for like having that large or like if you're is that when
Yeah.
you think it's
And if you're able to multi-thread, because some stuff that even is very memory intensive, but it wasn't written in a way that you can multi-thread, so
like
you're stuck.
Certain parts of R can be multi-threaded, but you have to use specific packages And a lot
Yeah,
of
it's-
things aren't compatible, like, a lot of our functions are not compatible.
Oh, yeah.
Same with Python. By default, Python will use one thread, and some programs you can take advantage of multiple. But there's also some overhead with splitting and pooling the results. So it can, if you have a small task and you're like, I want to do 32 threads, it probably will make it take way longer. So you have to
True.
really think about, is this even worth the overhead?
And is there a way, there isn't a way of knowing without actually doing it, right?
I don't think so.
Yeah.
Yeah.
That's what they
so
told me
everyone
too. And when I reached out to them, they were like, you just have to, you know,
Try it and see if it's.
you have to
faster,
try it.
basically.
Right.
That's why there's so many like parallelization benchmark like plots. You get very diminishing returns when you're
Yeah.
parallelizing on smaller data sets.
Okay. So this is the end of the batch jobs, the submitted jobs part of the seminar. Next, I'll talk about the interactive jobs, starting with command line, and the second part will be BioJ Hub with Jupyter Notebooks or RStudio. So interactive sessions or runs are called srun because slurm, so that's why. You can use from low to medium memory, depending which type of run you do. You can't ask for that many resources. Usually for interactive sessions, your runtime is kind of short-ish, as short or as long as you're willing to sit at your laptop, basically. Usually this is good for things that you're doing in real time, interactively. There's some kind of feedback that you're responding to, that you do at command line. So installing packages, debugging, testing scripts, things like that would be good to do interactively. And this is still done through this the scheduler. So when you this probably will look similar based on the first part that I talked about. So you still have to request basically a job on the cluster, but it's not a submitted job, it's an interactive one. So first, at your prompt, you will say srun, and then whatever kind of partition you want. So -p is for partition, free or standard. If it's standard, then you tell it which account to charge to, like your PI or your own. There's some optional things you can specify in there if you know what you're looking for, like either a particular amount of memory or whatever it is, right? And then two important parts you have to also specify is this bash pseudo terminal part. So you have to have this --pty and then this path to the bash interpreter. The default amount of memory that you get when you just ask for a srun will be 3 GB. And if you want more, you have to actually specify it this way. I'm not sure exactly, because you're already working on the terminal, but I guess maybe you can also ask for a like Python pseudo terminal. I'm not sure. I have not done that, but that's what it seems like to me that should be for that. Additionally, this is also optional, but if you do a lot of command line work and you want to see like plot results, you need to install some kind of X11 forwarding. On a Mac, it's through Xquartz, and I'm showing you here like a screenshot of what the icon looks like over here. And this you install on your laptop so that when you're working through the terminal on the HPC through your laptop, this Xquartz can help for you to like see the different plots that you're making. I kind of covered this, but again, the way that you would request the srun will be right after you log in. So if you know that you'll be doing some long or intensive work, you should go ahead and request it right away as soon as you log in. Don't do intensive things on the login node, or you will, yes, you will. So I'll show you an example here where you request that. You're put into the queue where you're waiting for the resources. Usually it's very quick, but sometimes you have to sit there for a few minutes until you're allocated enough resources. And the more you ask for, the longer the chances are you'll have to wait. Here's, again, the exact same way you check, you monitor your session, how long it's been running, how many CPUs you were given, the nodes, etc. When you want to quit your session, when you're done, just type exit and you'll be, the interactive srun session will be terminated. And then when you do SQ again, nothing should be there because your session was ended with the exit command. Here are some things you can do interactively. Again, like I mentioned, you can just, edit and test scripts of any kind. On the right, I'm showing you an R example. So you would have to load R, showing you here just regular R, but it'll give you the most recent version they have on there. But if you're looking for a particular version of R, you should specify it by module load R / or some kind of slash, and then the version number of that. I don't know if it's front or backslash.
Yeah.
Yeah. Here's a Python example. Same stuff applies for that one. So you can just do some kind of computations interactively on the command line on the HPC. You can also apparently on RStudio from here. It was very slow for me, so I don't think I recommend that. Plus, there's a better way to do that anyway, which I'll cover next through BioJHub. Before we go there, a couple quick tips. So check what's available, what kind of software packages, and load the right ones. By default, you'll be given the most recent version, but that may or not be the one that you're looking for. You don't have to install your own unless it's actually not available and you need it. A lot of stuff they actually do have installed for you because we all use a lot of the same tools, so they've already installed probably a lot of them. Check the manual for that package to see how it works. The way you do that is just type in the name of that package, for example, CellRanger. And
I've gotten into trouble when I do stuff like that because sometimes when you type in the name of the package, it'll start to run something. Like I've had that issue before.
Maybe okay.
Maybe
Well, so the issue is that some of the you're supposed to have a manual page, so you type in man and then the name. But like CellRanger didn't have that. Not everyone has a manual page. So you can also Google it.
Dash help.
Dash. Okay.
Tends to be more.
There's no catch-all.
Yeah. If they didn't make a help thing.
I would not recommend starting with just typing in the name of the, because again, like that might start to run stuff.
Some commands, like base commands, have like a lot of options, but -H does something else, like ls.
Oh, really?
-H does something. It's not help. It's just it makes
It makes it predictable. Yeah.
So a lot of things. Yep.
Even dash.
Good old Google has a way to go, maybe.
Yeah, maybe Google.
But I don't know. More complicated programs like CellRanger, you can be like or SAM tools or
yeah, that's I guess why I have this habit, because like you can just type in the name and it'll give you this. But yeah, good points, everyone. This is not catch-all.
Okay.
And again, ending the session so that you're not charged more than what needs to be charged, just exit out. Next, we'll talk about the.
One more point.
Yes.
For the previous one. If you're worried about losing your session and not being able to exit and getting charged, you should tmux your session because you will not be able to get back to it. Because if you start a session and like then you like disconnect from HPC, you can't get back to it.
So you can still look it up in SQ,
right,
and then cancel it manually that way.
That's true. But if you have like output loaded, then you won't be able to like get back to that. Right, so it's actually, I guess it's like twofold. It's more the latter.
tmux needs its own tutorial.
Yeah, that's true. I do not like tmux. I do not know why they got rid of screen.
Yeah, that would be another one, but yeah.
But yeah, if you want to reconnect to an interactive job after like dropping off Wi-Fi or something, look up tmux. It'll help you.
Okay, good point. So part 2 through BioJHub. So this is, let's see, which one is this? They recently changed it from BioJHub 3 to BioJHub 4. So if you used this a while ago, you'll have to probably update your address for this if you bookmarked it. But right now it's BioJHub 4. So you go to start my server, and then you would see the following options over here, which are probably by now very familiar. You're going to tell them on partition, which account to charge, how many CPU, and memory per CPU, and which container you would like to load. These are basically, I guess, so I have some, I guess, wet lab experience. So for me, this kind of reminds me of like using a particular kit. So everything in there is supposed to work together. It's a very specific lot number. It's just very nicely packaged and containerized, and you don't have to worry about versions of things changing on you. They're in a container and they're stable for a long time. Many containers are available, including some that were made recently by Ivan. So if Ivan somehow watches this, thank you so much, Ivan. This was really helpful. So in these different containers that are available, look for in the description for the name, what package you're looking for. Sometimes you'll see the version. If you don't really care which one, then pick one and just stick with it so that you're using the same version for things for your project. So once you select the container that you want and you press start, you will eventually be taken to a screen that looks like this. So on the left-hand side, you will have a bunch of different folders. Usually, I think you're placed into your home directory, but if not, then you can navigate wherever you want. So I usually work on our lab CRISP account or location. So I would scroll down until I see CRSP and then click there, and then find my way to our lab space. Next, you will select, or you can select which notebook you want, R, Python, or if you want to open RStudio instead, over here. And it will be made in the same location as where you are here on the left. So if you don't want your notebook to be in some obscure location, who knows where, then wait until you've navigated to the right place to make the notebook. When you make a new notebook, it'll look like this. So still on the left side, you'll have your navigation area where you will know where you are. Kind of like a lot of Office suite type programs have. You'll have at the top different tabs, like file, edit, whatever. Next, here for the notebook itself, you'll have similar things where you can save the notebook, add a new cell over here, delete one with the scissors, run, or also shift enter to run a cell. You can also not just run code here, but make like markdown, comments, things like that. So you can convert a cell from code to markdown using the drop-down box over here. Confirm that you have the kernel you're expected. So if you clicked on R before, this should be R here and not Python or something like that. And then the rest is basically you're running whatever script, I guess. So load your library, load your data, do plotting, whatever you want to do, and just save at the end. And next time you open the notebook, that those plots will still be there most of the time. And what else should I say about this? I think that's about it for this part.
Charge you? Is it like what does it stop charging?
This one, you do have to log out at the end, or it'll keep charging you. I'm not sure for how long. I think if you're inactive for a while, they do kick you off. It won't like deplete your account, I don't think. I think it's like a couple hours, but just to be safe, you should log out. And I'll cover that. Maybe use that next slide. Yep. So you would go to File, Hub Control Panel, and then you'll be shown this screen next, and just press Stop My Server. There is also an option to log out, but that does not stop the server. You can log back in, and your server is still running. So if you want to actually stop the run, you have to go and click this Stop My Server button. So what happens if the container that you are using doesn't have the packages you want? Well, so apparently in RStudio, you can install new packages that are not part of the container. They will only be available for you though. So another person that goes and uses this container won't have access to them. They'll have to install it themselves.
Did you reload that kernel, or do you have to reinstall?
I don't know for sure because I only learned about this particular thing very
Yeah.
recently, so I don't
Okay.
know.
Cool, that's also probably kind of inadvisable, just because of.
But I think
User
it's supposed to
errors.
stay.
That's cool.
Don't know.
I think if you log out from your RStudio, the package will be gone. So next time you have to reinstall it.
Oh, that's annoying.
I
But
think so, as far as I remember.
well, I guess then there's limited utility of this. Well, in that case, you can you have two other options. You can install it outside of BioJ Hub, like how when I talked about srun, and you can just install a package there in a different environment, or like in your, if you just only care about having one environment, then use your base environment, doesn't matter. And then do it that way. You can still open RStudio from srun. For me, it's been really slow. Maybe if other people have very good experience with that, I don't know. But a command line, you can run your package that way at least. It won't be through a nice notebook. Also, you can ask RCC to install a package for you. They do have a request email that you can just request package installations through, but be patient because they have other projects going on. So while they'll install it for you eventually, it won't be like next day necessarily. So keep that in mind. Yep.
One more thing I want to add is that for some of the container for the Python stuff, you can also install your packages. So some of the container for the Python, they don't like the right privilege. So you can also install packages for the Python as well.
Oh, do you mean because I'm saying here are, but I didn't say anything about Python?
Yeah. You can do it for.
That is true.
Yeah.
Yes. Sorry, Nargis, what are you saying? Not Nargis.
Yeah.
Yeah.
Similar.
Yeah.
Have you access and
In a notebook or something?
it's like the right?
Yeah, you can definitely do it in not BioJ. I don't know about BioJ.
I don't think you would do it by Java. At least a while ago. Well, this was on the old HPC. The answer was no. But I don't know about this one. I don't know. If you find out, let me know.
Do
That'd
you
be
know if
nice.
there's a maximum number of cores or memory for the
Yes.
BioJ Hub?
Yes. It is 16 CPU, and maximum memory per CPU is 6. So 6 times 16 is your max.
Okay, so like 96.
Yeah.
Okay.
I mean, that's not bad.
It's probably good for almost all purposes, except for especially for interactive stuff. Like
Mhm.
hopefully you don't have a ginormous data set. So
Right.
all your single cell stuff should be fine.
Yep.
Should be okay.
Especially with Srun 5 coming out, apparently they really improved that stuff. But let's see. Again, well, this is the end basically. I'm just gonna go real quick and mention that there are tutorials for a lot of what I covered today that I recommend that you read through. Even if you think you know all of these things, you might still learn something new. I did for sure. Of course, Google, Stack Overflow, or GenPALS. And if no one can tell you the answer, then we'll have to email RCIC and ask them. Some recommended courses if you're interested in this sort of stuff. So I personally took the first two, Fundamental Informatics and Advanced Informatics, and really, really learned a lot there. Very helpful. The third course I have not taken, but I've heard other people who have taken it also say very good things about this course, the Bioinformatics and Systems Biology, offered through the Neurobiology department. So you may be interested in taking these courses. And if you do use RCIC tools, then I think it would be appropriate to acknowledge them because Ivan has put a lot of work into these containers, at least in my experience. He actually made one specifically upon my request for like attack-seek things. So thank you. And that's it.